Hello again. Now that we've learned about stepwise slicing, we're ready to discuss conditional slicing. In this lecture, we'll introduce what it is and how we can use it with NumPy arrays. Let's begin. First off, we'll define the variable we intend to use. In this case, it's another 2D array filled with integers, so we'll call it matrix C. Just to be sure we've defined it correctly, we'll also display it on the screen. Fantastic! Okay, next we can slice the first column. If you need a refresher, we do so by taking all the rows and only the 0th column, correct? Yes, correct! Then you can copy this line of code into a new cell and add a simple condition at the end. Something like greater than 2 should suffice. The output is once again an array, but this time it's filled with true and false values. If we compare it to the slice containing the first column, we'll see that for every element of that array, we have an associated Boolean value. This true or false is based on whether the condition we set is satisfied. More precisely, we have false, true, and true. This is because from the first column of matrix C, only the first element isn't greater than 2. Now, if we remove the 0 index and put a colon instead, this will take the entire array as the slice. The output this time is a 2-dimensional array filled with Boolean values. We have true if the condition is satisfied for the corresponding value of the original variable, matrix C. All right, but what if we wanted to know the exact values which satisfy the condition? Well, to do that, we need to write the conditional part as an index inside the squared brackets. To showcase what we mean, copy the code where we determine which individual elements of the array are greater than 2. Then in a new cell, write matrix C, squared brackets, and paste the code within the squared brackets. The new output is an array containing all the values from matrix C greater than 2. However, unlike the previous result, this one is a 1D array. There are 2 reasons for this. First, NumPy doesn't know how many of the elements would fit this condition, so it can't create an ND array with a specific shape. Second, when we use this notation, Python takes the flattened array and applies the condition on it. Hence, it treats the entire matrix as a 1-dimensional array, where all the rows are stacked one after the other in the correct order. Of course, this condition doesn't always have to be greater than. We can change it to greater than or equal to by adding an equal sign after the greater sign. Alternatively, we can switch greater with less than, or even use an exclamation point with the equal sign to express not equal to. Using back-to-back equal signs checks whether the values are identical. Additionally, you can use more complicated operations like the percentage sign, which expresses remainder after division. For instance, if we check for percentage sign 2 double equals 0, we'll be filtering for all the even numbers in the set. Nice! Before we move forward, it's important to know we can have multiple conditions simultaneously. The syntax for this is very simple. Within the squared brackets, we write each condition in parentheses. Then between them, we add an ampersand. The ampersand is equivalent to the word and, since it makes both conditions valid simultaneously. Let's demonstrate this by filtering all the values which are even and less than or equal to 4. The output consists only of 4s, 0s, and a 2, which is exactly what we wanted. Now, if we only require one of the conditions to be satisfied, regardless of which one, we can change the ampersand with a vertical line. This symbol is the equivalent of the word OR, as it tells Python that if either condition is satisfied, it adds the value to the new slice. We see that the new array also contains even numbers greater than 4, as well as odd numbers smaller than 4. Hence, we've managed to filter out all the values that satisfy at least one of the conditions. Overall, conditional slicing is a fantastic tool to filter out certain data and helps us slice only the parts of the array we're interested in. All right, now that we've learned about the various types of slicing, we can move on to the squeeze function. In the next lesson, we'll talk about array dimensions and how to use the squeeze function to our advantage. Thanks for watching.